All right, welcome back. So the next set of preferences we're going to talk about are perfect substitutes. We're going to say that two goods are perfect substitutes if those goods serve the same purpose for an individual. In other words, we might think about, so the example we've already looked at, right, is Oxybucks versus dollars. If I'm going to spend Oxybucks or dollars buying pizza at the marketplace, then I really don't care which one I'm going to get. And I'm not going to get sick of dollars if I have lots of dollars and not very many bucks, or sick of bucks if I've got lots of bucks and not very many dollars, right? Because they're serving the same purpose. Another example might be different sizes of the same thing, right? I might consider 16-ounce bottles of laundry detergent to be perfect substitutes for 32-ounce bottles of laundry detergent, because all I really care about is the amount of laundry detergent I have. So if I have lots of large bottles, that's not going to make me want to get a small bottle just to mix things up. Okay, so to think about what this is going to look like mathematically, let's take one specific example. Let's imagine that you can either buy small containers or large containers of something like toothbrushes, right? You go to the pharmacy wanting to buy a toothbrush, you can either buy individuals or you can buy 2-packs. So we'll call the individuals smalls and the 2-packs larges. We might say that your preferences could be represented by a utility function. Looks like this, U of L and S equal to what? Well, if all you care about is the number of toothbrushes you have, right, then a large, which has 2 toothbrushes, should be worth twice as much as a small, right? So it might look like 2L plus S, right? Because each large pack has twice as many toothbrushes as a small pack, and so it's worth twice as much to you. Okay. And more generally, right, if we wanted to consider any two types of goods, we might say that U of X and Y, right, is going to equal some number A times X plus some number B times Y. Anytime that we can write our preferences in this form, we have perfect substitutes. Okay, cool. So what does this look like? Let's look at this example just to make things concrete, right? So in this case, right, we have obviously A is 2 and B is 1. So let's draw an indifference curve. I put larges on the horizontal and smalls on the vertical, right? I'm going to draw an indifference curve. Let's pick one particular value. So let's say, for example, 2L plus S equals 8 is going to be our indifference curve, right? All the values that add up to the same utility value. So then, of course, we would say S equals 8 minus 2L, right? Which is just the equation for a line, right? So what's our indifference curve going to look like? Well, it's going to have a vertical axis of 8. It's going to have a horizontal axis of 4. And it's just going to be a straight downward sloping line. Right, if we drew other indifference curves at different values, this one's no good. We drew other indifference curves at different values. All of them would be straight. All of them would have the same slope. And what's that slope going to be? Well, we know that the slope of an indifference curve is always given by our MRS, right? So let's calculate the MRS for the amount of y that we'd be willing to give up to get an extra unit of x in this general case. So we would say our MRS, yx of x and y, right, is going to equal du dx over du dy. We'll say du dx is going to be, well, derivative of a times x with respect to x is just a. Derivative of b times y with respect to x is 0. So just a, and du dy is going to equal b. So in general, the slope is going to be a over b. Right, in this case, this would mean that our slope would be 2 over 1. It's just 2. This means that we're willing to give up 2 small packs for each large pack, and this makes sense because the large pack has twice as many toothbrushes as the small pack. Okay, cool. So in order to think about how to solve problems when we have perfect substitutes, I want you to notice something really important about this MRS, which is that it's not a function of x or y, right? The marginal rate of substitution at any value of x and any value of y is just going to be some number, and that number is a over b, right? So in the 2-pack, 1-pack example, this number was 2. In the Oxybucks versus American dollars example, this number was 1, right? But in both cases, it doesn't matter how much of either good I consume, the MRS never changes. And that's why our indifference curves look like straight lines. So as a result, if we think about trying to optimize, right, find our optimal choice on some budget constraint, where we have good y and good x, and we have a slope given by px over py, right? The slope of our budget constraint is constant, and the slope of our indifference curves are constant as well. So we're not going to be able to find an interior solution, right, some spot on this budget constraint where the MRS equals the price ratio, unless A over B just so happens to have the same slope as Px over Py. In other words, if we imagined a situation where A over B was less than Px over Py, right, then we would have indifference curves that have a shallower slope than our budget constraint, right? This is where A over B is less than Px over Py. In this case, we'll never find an interior solution, right? Because at any point that we choose along our budget constraint, the slope is going to be shallower, our indifference curve is going to cross our budget constraint. Instead, the only solution we'll be able to find, right, is one in which we're at a vertical corner. The reason is if we remember how to find corner solutions, right, if we're at a vertical corner and our MRS is less than our price ratio, that has to mean, as you can see on this picture here, that everything above our indifference curve is going to be out of our budget constraint, right? It's going to be infeasible to us. So one thing we can say about any perfect substitute problem is vertical corner if A over B is less than Px over Py, right? The slope of our budget constraint is steeper than the slope of our indifference curve. If we think about what this means, right, it means that the amount of y we're willing to give up to get a unit of x is always and everywhere less than the amount of y we'd have to give up to get a unit of x. So we won't give up any y, we won't get any x, we'll be at a vertical corner. Cool. So how about if the slope of our budget constraint was less steep than the slope of our indifference curve? In other words, what if A over B was greater than Px over Py? Well, then we would have indifference curves that look like this, right? We would say the same thing at any interior solution, right? This can't possibly be optimal because we could do better somewhere over here, right? We're always going to have indifference curve cross our budget constraint, so we have to have a corner solution. Which corner is best? In this case, it's going to be the horizontal corner, right? So this is where A over B is greater than Px over Py. In other words, the amount of y I'm willing to give up to get a unit of x is greater than the amount of y that I have to give up to get a unit of x. So what do? I buy all x and no y, right? So we'll have a horizontal corner if A over B is greater than Px over Py. And then the last possibility to consider, right, we know what happens if our MRS is steeper than our budget constraint. We know what happens if our MRS is less steep than our budget constraint. The last possibility is that our MRS is as steep, exactly as steep as our budget constraint, right? So we have an indifference curve that falls right along our budget constraint. Oh, this is terrible. Difference curve that falls right along our budget constraint. Right, indifference curves that are above or below our budget constraint. And in this case, what we're going to say, right, what we're going to say is any point on our budget constraint, every point on our budget constraint is on the same indifference curve. Everything better is not feasible. Everything off of our budget constraint is, of course, worse. So it won't actually matter which of these points we choose, right? Every single one of them is just as good as any other. In other words, right, if I can buy an oxybuck for $1 and I'm willing to trade one oxybuck for $1, then it doesn't really matter how many oxybucks I get and how many dollars I get, right? Any choice I make is going to be optimal. So any point on budget constraint optimal if A over B is equal to Px over Py. Cool. So just to sum up, when we have perfect complements as our preferences, we're going to have constant marginal rates of substitution, we're going to have linear indifference curves, and we're going to have corner solutions effectively all of the time. There's never a point where one of the corners is not a solution. There's just one special case where interior solutions are just as good as anything else. Okay, great. So in the next video, we're going to talk about perfect complements, which are essentially the converse of perfect substitutes.